Perfect. So for the folks on the stream, we're just getting started here in the room. There's a link on the screen if that's coming through yet to join Spinnaker Slack if you haven't already. We're going to use generated credentials to a shared Kubernetes cluster today. So I can send you those credentials in Slack as I create them. It'd be helpful if you just shared like a username. It could be your GitHub handle. It could be a random string of letters. Just something that I can use to create something for you. And I'll repeat that for the stream as well. So I'm going to go ahead and create a channel, and then I'll put it in the terminal up there so that you can see it, and then just message if you need credentials, and then I will send them to you directly. Great. So it's going to be the SpinSum 22-contributors-workshop. think I've gotten everyone. Has anyone not received a DM from me? No? Okay. Let's go ahead and get started then. So thanks all for coming. We're here to learn more about becoming a contributor to the Spinnaker project. We've been learning a lot about Spinnaker over the last 2 days, and it's exciting to see all of the new faces here, all of the new contributors to the project. So what we're going to try and do today is equip you with all of the tools that you need to get started actually contributing code to the project. Of course, that's not the only way that you could contribute. There's also being able to use the product, find issues with it, file it in the issue tracker, contributing to documentation. There's a number of things that you could do within the project that are still valuable work. Today, though, what we are going to focus on is how to actually make changes. And we're going to do so in the open source project in particular. And if we are able to get through most of the content, then we'll start to focus on some plugin development towards the end. So to start off, I want to make sure that we all have a baseline understanding of architecture within the project. So I'm actually going to duplicate this on my screen so that I'm not constantly looking over my shoulder. Perfect. Okay, so what we have going here is the architecture for the open source Spinnaker project. We're going to focus on the center square in the center of the diagram, and then we'll talk a little bit about stuff on the periphery, but we're primarily going to focus on the services internally. So as we're all familiar, Spinnaker is a platform for doing continuous delivery, right? Being able to orchestrate pipelines and deployments across a number of different targets and cloud providers. The way that that gets consumed is by each of these individual services. And we'll go into a little bit of a history lesson here, but when Spinnaker open sourced the project initially, their goal was to create microservices per set of features or a part of the domain, right? A slice of the pie. So each of these services, they all focus on a different aspect of continuous deployment, and they all follow similar patterns underneath. So the theme that we're going to see throughout the day as we work on some of these services is how do we, how does data get into the platform, and then how is that data exposed to other services? So the most common pattern that you'll see in each of these services is I'm going to go pull for information from a remote system, and then I'm going to cache that internally, and I'm going to expose that information to other services. And the reason it was designed this way originally is so that downstream services, things like Jenkins, things like Docker, were not going to be severely impacted by the sheer number of calls that were being made by the Spinnaker platform. So the goal was to get all of that data in-house and then make it available to other services within the Spinnaker ecosystem, and then allow developers to describe their deployments from there. So what we're going to do is we're going to go through a brief overview of each of the different services so you understand how they interact with each other. There's a lot of arrows on the screen. Let's not worry too much about the arrows for now and just focus on the individual services within that core box. So starting in that top row, we have Deck, Gate, and Igor. Deck is considered the front door of Spinnaker. It's the front-end application that provides all of the nice GUI features that users end up seeing the most. Gate is considered the API gateway for the whole system. So if you're familiar with microservice architecture, you generally have something sitting at the edge that exposes functionality for a whole bunch of internal services. So Gate is going to be the one exposing all of the high-level functionality that Deck will use. And if you're integrating with the Spinnaker API, more often than not, you're going to be integrating with with Gate. You're not going to be interacting with individual services unless you intentionally expose them. Then the last one on the top row here is Igor. Igor is the service that is responsible for CI artifacts. So it's going to interact most often with Jenkins, with Docker, with some of these other artifact-like systems. And again, that pattern of caching resources and then making them available, Igor will take, for example, all of the Jenkins jobs in your Jenkins cluster and then expose them as jobs that you can then reference or trigger pipelines within the system. Then in that middle row, we've got Kayenta, Orca, Echo, and Fiat. So starting on the left, Kayenta is the service that is exposing or responsible for the domain of Canary deployments. So when you, are we all familiar with Canary deployments? Is that well known? Okay. So Kayenta will be responsible for aggregating data from different metrics providers and then exposing that along with judgment functionality for other services within the system. So for example, if you're trying to determine whether a service is healthy in production, Datadog is your provider. Kayenta is going to be responsible for ingesting metric data from Datadog and exposing a way for you to create a judgment, like CPU, if CPU exceeds 50%, then fail the judgment, right? Next on the list is Orca. Orca is probably perhaps the most involved service within the cluster. It's responsible for orchestrating the rest of the services. So when we start to get into the actual workshop today, what we're going to see is that Orca is responsible for making sure that a pipeline definition, which is composed of stages, which is composed of tasks, is executing all of these things in the correct sequence. So it's going to take this graph and it's going to go through the graph and make sure that each of those things are being completed. And if they're not, then they'll end up reporting status back, right? And that's how we end up seeing errors in the deck UI. Then we've got Echo. Echo here is our notification service. So all notifications end up going through this system. A lot of things that end up triggering deployments will go through Echo first. So it's going to broadcast messages and make sure that other services are aware of what needs to happen. Echo is probably, if Orca is the most complex, Echo is one of the simpler services that you'll end up seeing today. And then we've got Fiat on the far left of this middle row. And Fiat is providing authorization, auth-n, and authentication, auth-n, and authorization, auth-z, right? So those two pieces of functionality are being provided for the rest of the cluster. So for example, when you execute a pipeline and you're authenticating with a SAML provider, then a check will be made to Fiat to make sure that you have permissions to actually execute that pipeline. And Fiat will just return that value for other services to consume. Then on the bottom row, we've got Roscoe Cloud Driver Front 50. Roscoe is the service that's primarily providing baking functionality. So are we familiar with the concept of baking and like immutable infrastructure? Yeah, seeing some nods. Okay. So Roscoe will allow you to bake an AMI, for example. It's also responsible for rendering, Kustomize, and Helm-based manifests when you're deploying to Kubernetes. And Cloud Driver is the abstraction for all of the different cloud providers. So when you want to deploy an AMI, or you want to deploy a Kubernetes deployment, or you want to retrieve the status of a load balancer in Azure, all of those operations are going to be encapsulated inside of Cloud Driver. So it's responsible for wrapping all of the cloud-specific SDKs and then providing a consistent interface for the rest of the services to interact with. Then on the bottom right, we have Front 50. Front 50 is considered the persistence or the storage layer within the project. Anything related to application pipeline or Canary metadata will end up being stored in this service. And then, it's got a number of different backing stores. You can use the object stores in your cloud, or you can use Minio in cluster, or for most production use cases, you can use a SQL backing store, which is definitely something that we recommend. So the last thing I'll mention around all of these services is that by default, and you'll see this today, the backing store for most of these services is going to be Redis. Redis is, of course, not a persistent store, but it does make it simple to get started, right? Really what we recommend if you start running Spinnaker in your own environment is to choose a SQL-based backing store. So you can do SQL or Postgres, but again, today we'll just focus on the Redis client. So I'm going to stop there and see, do we have questions either on the stream or in the room about any of the services or kind of basic architecture principles? Perfect. Okay, so if you came to or saw some of the talks yesterday, you might have seen a couple of different ways to get all of this stuff installed and configured. Today, the shared cluster that we're going to be using is using the open source Spinnaker operator. And then we'll use Kustomize to install that Spinnaker cluster within a namespace. So the credentials that you've received will give you access to a shared Kubernetes cluster. You'll have effectively admin access within your namespace, but you won't be able to go into other namespaces, so don't worry about that. And then the reason that we're wanting to do this is so that we can run most of the Spinnaker services in this remote Kubernetes cluster, and then only modify the services that we need to on our local machine. So now we'll get into a little bit more of the development setup. So what we're going to go through today is setting up our editor to make sure we can actually work on the project. Talk a little bit about strategies for working with this remote Kubernetes cluster. And then we'll actually work on Orca to enable a new stage within the project. So we're going to need a few tools locally. We're going to need, and I'll put them up on the screen now, I suppose. So we're going to need kubectl to access the cluster. We're going to need Telepresence, which is a tool for creating that bidirectional proxy between our services on the local machine and our remote cluster. Some kind of editor. We're going to be using IntelliJ IDEA. You can use the community edition. It's free if you're not already using it to work on some of the Java services. You can use IntelliJ for the front-end services, but otherwise we'll show you how to get this all set up in VS Code. And then what's the last thing that we need? There's one other thing. I think that's it, actually. So we'll start with this set. Do we need to, well, actually, let's give folks like 4 or 5 minutes to make sure that they have all this stuff on their machine, and then we'll go ahead and move on to the next step. Good to go? Do we need a few more minutes? Okay.
When will we need it? When will we need it to tell you? Probably later on?
A little bit later on.
Okay, cool.
Yeah.
I'll keep it on.
Okay, perfect. Yeah, for sure. Okay, so we're going to talk about the next phase. So we need to go ahead and get Spinnaker running inside of our namespace. So in order to do that, we're going to use Kustomize and the Spinnaker operator to accomplish that. So I'm going to go ahead and put this on the screen here. So what we're going to use to help us get through this today is the, too bad I can't mirror the browser window. Anyway, we're going to use this project to jumpstart our ability to get Spinnaker running inside of the cluster. So what this repository does is it takes a bunch of common configuration patterns within the Spinnaker project and then allows you to apply them using Kustomize, and it gives you like a nice big Spinnaker service CRD that you can use to apply to the cluster. So to cover hopefully unfamiliar ground here, the operator is a Kubernetes operator that manages the lifecycle of Spinnaker within a Kubernetes cluster. So the way that it accomplishes that is it extends the Kubernetes API by creating what's called custom resource definitions, or CRDs for short. And those CRDs give you the ability to have some configuration of a desired state and then have the operator realize that desired state inside of the cluster. So in this case, the Spinnaker service CRD has a whole bunch of different configuration values. They'll be in the same format if you're familiar with Halyard to actually create, I want a Spinnaker cluster with a Kubernetes account and I want it to have, X permissions and the ability to, access Y S3 buckets. And then the operator will create all of the configuration necessary for that and start up all of the services that we were just talking about in that architecture diagram. So this repository will make it easy for us to get started. You can either use it as a template or you can clone it directly if you want. I'll go ahead and post this in our channel here so you have easy access to it. And I'm going to So if you use the template, what that's going to do is it's actually going to fork the repository and create it in your own space. And then from there you can clone it. So I'm going to swap over to our area here. I'm going to go to our Kustomize patches. Perfect. And I'm actually going to make sure that I'm on the right checkout. Perfect. Okay, so what you'll end up finding in this directory is a whole bunch of different patches that you can use to configure services. So what we're going to look at first is this Kustomize minimum, or this recipes Kustomize minimum, and I'm going to make sure that this is correct for you, so you're not constantly switching colors here. And so this is the simplest possible definition that we can make for installing a Spinnaker cluster. So this customization, what it's saying is namespace Spinnaker. What we're going to want to do is change this to the name of the namespace that was created for you. So for example, if I was creating my own namespace here, I would change this namespace to Freire. And what that's going to do is it's going to map all of the resources that are being created in this Kustomize block. They're all going to be mapped to that namespace. So you don't have to manually go into each of the manifests and say, I want to change the namespace here. No, Kustomize will take care of that for you. Then we've got a components block, and that's where we're going to pull in the bulk of our configuration today. So the first that we're going to look at is core base. This is just going to define the base Spinnaker service CRD. Then in the next value, we're going to define in-cluster persistence, and we'll go look through all this configuration so you're at least familiar with it. And then we're going to define a Kubernetes target. So when you first stand up Spinnaker, you'll be able to go in, create pipelines. You'll be able to do a simple deployment to the current namespace that you're in. Then at the bottom here, we're going to patch the version in. So in this case, we're going to make some manual edits here. This repository is primarily geared towards deploying our proprietary version of Spinnaker, but with a change to this version patch and the addition of another patch, we'll be able to install open source Spinnaker, no problem. And then the last one here, we're actually going to remove this transformer. How familiar is the group with Kustomize? I don't want to go too medium-ish. Okay. Okay, so I'll briefly explain this, but we're not going to end up using it today. So what this transformer block does down here is it actually takes a set of resources and then prefixes or suffixes a value. So in our development cluster, for example, our engineers are usually working with a cluster admin role because it's a development cluster. And those are global resources. So having a transformer like this makes it easy to prefix the cluster roles so that we're not stepping on each other's toes when we're actually doing development. So we'll go ahead and remove this transformers block. And then while you're cloning this repository, kind of getting familiar with the space, I'll go into definitions of components here. So I'm going to have a split here so that we can look at both values in turn. And then I'm going to go to core base. And we'll see here the introduction of a component type in Kustomize. So this might not be familiar to a lot of folks. This is something that was introduced in Kustomize 4. And components give us the ability to group a whole bunch of different customized resources together and then expose them like we do in our top level manifest over here. So it's a nice way to kind of abstract away a lot of configuration that you may not want your end users to worry about too much. So in this case, all we've done is define a Spinnaker service. This looks interesting. That looks a little bit better. And we can see here that we have a top-level spec with our Spinnaker config. Everything under Spinnaker config maps to equivalent HAL config values. And there's definitions and descriptions of all this stuff in here. But of course, the open source website also describes these things. And then we have the ability to set individual, we have the ability to set individual settings on the services that are created for each of these services, as well as how we want to expose them, and then any runtime configurations that we want to make to the cluster. Now this bears a little bit more explanation. So this Kustomize block, it might be weird to think of using Kustomize and then have a Kustomize definition inside of the operator. The difference between the Kustomize that you define in this manifest and the one that we're going to be using today is that this allows you to do runtime patches within the cluster itself. So what's nice about this, for example, is if you need to attach a sidecar to all of the different services and you want to do that dynamically, you don't necessarily want to have to define that up front. You can define that in this Kustomize block and it'll do it on the application side. Or maybe you need to do a more fine-grained addition of labels inside of the project that you don't necessarily know up front. Kustomize will help you do that here. But this is more of an advanced feature. We're definitely not going to dive into it today. Okay, so we've gone through our core definition here. We're going to quickly show what in-cluster persistence looks like. So we'll go down to our persistence directory. You can, of course, switch to S3 if you want to work on this in your own cluster, but you don't have permissions to do that today. So we'll stick to in-cluster. And in the in-cluster config, we're going to stand up Minio. Minio is an open source key value store that is S3 compatible. So if you ever have a need to test something in an S3-like environment locally, Minio is a great solution. That's what we're using today. And then we're going to be generating a secret here, which is super secret. You're all going to have the same secret. And we'll go into Spinnaker config and we'll see how we actually configure this. So we're going to define persistent storage. We're going to lie to Spinnaker and say we're deploying to S3 or we're persisting to S3. Spinnaker won't know the difference. And we're going to tell it what bucket we want to deploy it to. This name usually has to be unique, but because we've got our own Minio cluster, it doesn't really matter here. So all of this will just help you deploy to Minio in your namespace. And then the last thing we're going to talk about is our Kubernetes patch. So we're going to go down to targets, Kubernetes default, and then we can look at our customization here. And this is basically the same pattern that we've seen before, right? So there's going to be a whole bunch of stuff that we're going to bundle together. And because it's exposed in this top level configuration, we don't have to worry about it too much. But the gist of what we're going to do here is we're going to create a service account with a role binding that will then apply to that cluster. So let's go ahead and talk about how we're actually going to get this applied. So let's, if we go to the root of the directory, so let's go here. If we go to the root of the directory, you'll see that there is a customization.yaml file. This is actually pointing to a much larger customization file. We're not actually going to end up using this one today. So there's two approaches that you could take. You could either move it from recipes, customization minimum, to the root of the directory, or you can create a new symlink. I'm just going to go ahead and move it. And then what we should be able to see when we do a customized build is something like this. So we'll see all of this information being generated for us, including any claims that we need for Minio and all the other related resources. Let's go ahead and make sure that was the right file. I see. When I did the move, I did not do the move correctly. So I just moved customization minimum into the current directory, and what I should have done is rename the file. So now if we do a customized build, we should see the resources that we expect. Okay. So I will pause there and see if there are any questions so far, because there's a few more changes that we need to make before we can actually apply this to the cluster. Okay, so one of the last things that we need to do here is we need to make sure that we're installing the open source version of Spinnaker. If you look at any of these individual patches, what you're going to see is that the namespace looks like it's not open source. So let's go look at like targets, for example. And let's look at the provider definition here. So CRDs, they're bound by something called a group version and a kind. So in this case, the group and version is this API version here, spinnaker.armory.io/v1alpha2. So what we're going to want to do is we're going to want to introduce a patch which is in the utilities directory that will change this API version to spinnaker.io/v1alpha2. The only functional difference here is that you're only going to be configuring the open source functionality that's in there. And of course, we've already got the open source Spinnaker operator installed, so we don't have to go through all that. But then the kind Spinnaker service will be the same between both API versions. So this is neat. If you end up getting into the operator world, it's a neat way to kind of segment configuration values. So let's close this up, and let's go ahead and open up a new split, and I'll show you in the utilities directory. We have a switch to OSS patch here, and you'll want to grab this configuration here, this block of configuration from line 8 to about 11, and dump that into your minimum value. And then however you choose to uncomment that value and maybe indent it correct way. So now we've got a patches block targeting Spinnaker kinds, and the path is set to switch to OSS, and we can just inspect the patch here. It's very simple. We're doing a replace operation on the API version path. This is a JSON path, so if you need to do something more specific inside of a CRD that you're trying to modify or any Kubernetes manifest, you can specify that here, and then the value that you want to replace it with. So here we're just saying replace it with spinnaker.io/v1alpha2. And now when we go ahead and look at our customized build and inspect what we're doing here, we've got our API version not set to the correct value.
Need to get a customization.yaml rename.
Come again?
Is that right?
You know what I did is I left this file open, and it's modifying it in the recipes directory.
Okay.
So we're going to go ahead and close this one, and we're going to open up the correct one. So now in the root of the project, we'll go ahead and paste this, uncomment it, throw it back where it should be, and when we do our customized build, we should now see the correct value. Great. Okay. And now the last thing that we'll do before we go ahead and apply things, now that we've got our open source patches, we'll of course need to change this version. So we should open up our core patches version file and change it to 1.29.0, which is the version that we'll be working with today. Okay. So once we've got all of this applied, I'm going to go ahead and queue up our command here and then explain what we're going to do. Your ns-k dot. And let's maybe, there we go. Perfect. Okay, so I'll wait there, and then let's see if we have any questions before we move on.
Would you want that version? What is that version again? Is that like a new file, or is that in the root, or?
Yep, so it's already included in the core customization file. You just got to go to core/patches/version, and then change that to 129.
Okay, cool.
Yeah. Yep.
I read it late. Is there a way to create a namespace, or is that?
I will create one for you,
Okay.
and then I will send it to you on Spinnaker Slack.
Thanks. I think someone else might be.
You as well? Can I get your name? Heinrich? Okay. It does.
Did you have to like do a wrapper?
Mm-mm. That was like a whole drama some years ago. I guess the question for the stream was, does Kustomize come bundled with kubectl? Yes, much to the consternation of the Helm community. You will, so one thing that we'll see when we go ahead and apply this is you might see some errors, and if you do end up seeing errors, the likeliest explanation is that your version of kubectl is older than what we need to use today. So kubectl before version 121 shipped with Kustomize 3, and kubectl post 121 shipped with Kustomize 4, and Kustomize 4 is what we're going to be using today.
Do you recommend like through installing the direct, or should you just let it ships the work?
If you brew install, I believe that will get you the latest, and it'll always keep you on the latest. Yeah, yeah, yeah. And we're familiar with like Kubernetes version skew. Is that? I mean, you probably are, but folks in the room. Okay. Are you familiar with like version skew and Kubernetes and what that implies? Okay, perfect.
Yeah, it doesn't have try to do I must be using a different.
Oh, interesting. Yeah. So I keep a version of 122 and 119 just to capture the spread of clusters that we have to work with. Shoot, let me keep that going, and then Heinrich, I will generate your cluster right now. Okay. Mm-hmm. Perfect. All right, so I'm going to go ahead and explain what we're going to be doing next. So we have, I've just created a quick namespace for myself just so that I can follow along with you. And we're going to run, I guess let's talk a little bit about the kubeconfig file that you have. So that's just has static credentials to the cluster that we're going to be working in today. My personal preference is to store kubeconfig files in individual files and then reference them in each command. I like to be explicit, but that's by no means the only way that you can use these kubeconfig files. You can go ahead and merge this with your core kubeconfig file if you want, or you can use something like kubecontext, or I don't know, there's like a number of tools to manage kubeconfig files for you. So that's what you'll see me doing today. I've also got my kubectl command alias to KC, because I like typing less letters. And then I'm going to be prefixing my commands with a namespace, but you don't necessarily need to, since you will only have access to the one. I don't know if I set that. What you could do, yeah, what you could do to confirm is you could actually go open up that kubeconfig file and then see if a namespace was added to your. It did? Okay, good. Past Fernando was smart and included that, so you will not need to worry about the namespace today.
Yeah, maybe we should just double check.
Yeah. Okay, so I'm going to go ahead and run this and see that things failed because why? That's bizarre. Oh, because I'm missing the verb. Excellent. So when we run this command, what we're saying is go ahead and use these credentials. Go ahead and dump it in this namespace, our verb. Of course, we always have to have a verb when we're using kubectl. In that case, it's going to be apply. And instead of -f, which is probably what we're used to seeing, you can do a -k. And that's going to tell kubectl to use Kustomize instead. And then the additional argument to -k is the current directory, because we're going to be using the current directory where that customization.yaml file is. And this exact error is what I'm talking about here. If your kubectl version is too old, you will see this error. So instead, what you're going to want to do is have a newer version handy. So I'm going to go ahead and grab it from yesterday's demo, and I'm going to use that instead.
Did you install the operator earlier?
I did install the. Ooh.
It's not from the Spinnaker service. I don't know, I walked in late, sorry.
No, that's okay. No, totally fine. Yeah, so the open source operator is installed already. So all we have to worry about is our Kustomize config today. And it looks like there is an issue here. So we get to triage this. This is always the fun part of live workshops, right? So we created an object that doesn't match the namespace. This is coming from our suffix here. So did I do a bad thing and not remove the transformer? I think that's was the issue here. No, we just get less errors now. Okay. So if you were following along here, this transformers block was originally left in. I told everyone to remove it, but let's make sure that we remove this. We don't actually need the unique service account here. Let's go ahead and run this again. And then let's assess where the Spinnaker namespace is being defined. So let's go ahead and do, this is not exactly what we want here. So let's go ahead and look at this spin cluster role binding is coming from our Kubernetes component. So let's go ahead and look at our component here and then understand where this is from the role binding. So these are all going to be cluster level resources. So we're not actually going to want this. So we're going to do a little bit of live editing here. So what we're going to want to do, let me go ahead and open up our customization file. So we're going to be editing files inside of the target Kubernetes default component. So the first file that I'm going to modify here is going to be our provider. No, the provider is going to be fine. But we are going to want to change our service account and service account bindings. So instead of cluster role, any instances of cluster role that we see here, we're going to change to role. And then inside of service account bindings, we're going to change our instance of cluster role to role. And when we reapply, we should see a different error. Interesting. So there's another instance of cluster role that we might not have removed from this directory. And that's going to be all instances of cluster role binding. Okay, so let's go into service account, cluster role binding. Go ahead and change this to role binding. And then if TFR here, change this to role binding. And then in our service account bindings here, change this to role binding. Perfect. So then let's see what our next errors are. This is quite curious. Oh, I need to change. So I had not changed this in the other file. Okay. Well spotted. Okay. So now if we've successfully managed to run this command, we'll see that all of our resources are created here along with our Spinnaker cluster. So I'm going to leave this up and then see where folks are at. See if they've had trouble applying things. So the operator is going to run in two different modes. So you can either run it in a basic mode, which is only going to have access to the current namespace, or a cluster mode, which is what we've done in this case. And in cluster mode, it's going to watch all namespaces for any application of a Spinnaker service CRD, and will manage the creation of that. No, it's okay. Yeah, no worries.
Yeah, I changed the concept for my shells. I didn't refresh
Mm-hmm.
Can you show your final customization YAML on the screen?
Can I show my customization YAML?
Yeah, on the screen.
Oh, yeah, of course, of course. Yeah, so I'll show you what I got going here. Also add today, we're running inside of a shared Kubernetes cluster that has enough resources for us all to play in. But this approach that we're working with here is going to work just as well if you have sufficient resources on your local laptop. So typically what we recommend is you have somewhere between 8+ cores and 32 gigs of memory. And that should be sufficient for your machine to not cripple and die and also run all of the Spinnaker services. So you can do that in Minikube, you can do that in Kind, you can do that K3s if you want to run K3s, any number of Kubernetes clusters. You should see if you've managed to run that kubectl apply is if you do a get pods inside of your namespace, you should see not only Minio, but all of our open source services running here. And you may see, it's possible, like you can see here, Orca restarted once. It's possible, depending on how quickly we were applying this, that it just took a little bit of time for the service to become healthy. But you should eventually see after 2 or 3 minutes that all of the services are up and running. go ahead and get started. I think most folks have been able to get up and running. If you haven't, feel free to drop a line in that Slack channel or raise your hand, wave your arms wildly. Okay. So what we're going to do next is we're actually going to start working on some of the projects here. Before we do that, I want you to make sure that your cluster is working the way that you intend it to. So I'm going to go ahead and create a new split here. And we're going to port forward a few services to our local box. And the reason we want to do that is because the cluster is running in a remote location. If you want to do this in your own environment, you can set a load balancer setting in your Spinnaker service CRD, and that will generate classic load balancers. So that's going to create 2 ELBs, one for gate and one for deck. We're not going to do that today. We're just going to be port forwarding to our local machine. Luckily, that is fairly straightforward to do. So again, I'm going to be specifying a namespace because I'm running with a different kube config, but you should be able to follow along here. So our verb is going to be port forward, and then we're going to port forward, in this case, 2 services. So if you're unfamiliar with kubectl here, we can shorten service to SVC, and then we're going to do spin gate and port forward 8084. A little bit of shorthand, if you're going to be port forwarding to the same port in kubectl, you can just specify the ports once, and it will go ahead and port forward that. And then in a separate split, we're going to port forward spin deck to 9000. And again, thinking back to our architecture diagram, gate is the API gateway to the whole Spinnaker platform, and deck is the front door that we're actually going to go to in our browser. So if you've successfully been able to port forward, you should see these 2 messages here. We're going to want to keep these open off to the side and just kind of out of sight, out of mind while we work on a few things. And what you should see is if we go to localhost 9000, do I have any other port forwards going? Don't think so. So what I'm going to do, just because I tend to work on this quite a bit, is I'm going to clear my cache. And then once it loads up correctly, I will bring it up onto the main screen. So I'm going to go ahead and bring this over to the main screen. So this is a variation of what you're going to see if your Spinnaker is working correctly. So what's going on here is that I've got a cache from a different cluster that I port forwarded to my local machine. So these are resources that are just going to be from that other cluster. They won't actually be able to navigate there. So what we've got is the base Spinnaker UI. I'm going to assume we've all used Spinnaker before. Is that a fair assumption? Okay, so we're not going to dive into the UI too much here, but we should be able to create an application with some demo values. And create a very simple deployment. Usually what I end up doing is Googling Nginx deployment as the base resource. It's usually from the Kubernetes docs. And just grab this fella. And we're just going to create a simple deployment here to make sure that everything is wired up correctly. So we'll go ahead and configure a new pipeline. Going to add a deploy manifest stage. Select the Spinnaker account. So Spinnaker is just the name of the account that was created by default. You can, of course, name your account anything. You'll need to go into that target/default/Kubernetes/default directory, and in there the account definition will be named Spinnaker. So you can of course call this whatever you'd like, and then I'm going to override. Well, we're not going to override the namespace here. Dump in our artifact for Nginx, save it, and then run it. And that should tell you if your cluster is up and running. So I'm going to pull that back over here, because really I'm going to start talking about the next stage while you're all doing that. So what we're going to be doing today is we're going to be working on 2 services, but really 1, just for the sake of time. We're going to be adding a new stage, and in this case we're going to be adding that stage to Orca. So let's talk about the use case, why you might want to do this. So if you, how many folks attended the talk yesterday about like plugin development? I got 1, 2, yeah, perfect. So the same use case applies there. I'll recap it for the folks that didn't attend the talk yesterday. Spinnaker is a very mature platform. Its feature set covers 90% of the use cases that you will have when you want to do a continuous deployment. Those other 10% cases are going to be specific to your organization. And that's going to be integrating with like a custom internal API. It's going to be doing something for compliance reasons. It's going to be, sending metrics to your bespoke, metrics provider. Those things that are like specific to your organization, but are not necessarily going to be something that benefits the community at large. Those are going to be the things that you want to extend here. And ideally, you'll do it as a part of a plugin. But today, we're just going to work on stages and tasks and the front-end work inside of the open source services. Yeah, again, ideally, you'll go through the plugin framework, but just for the sake of working on something interesting, we'll be doing that in the open source projects. So what we're going to need to do that is we're going to need to clone 2 different repositories, and I'll explain how we can follow up with the deck stuff after the conclusion of the workshop today. But if you go to github.com/Spinnaker, that's going to be the homepage for all of the projects. And then if you go to /Orca after that and /deck in another tab, you're going to get to the 2 repositories that we have here. And we're going to want to make sure we clone those to our local machine, because those are the services that we'll actually be building and running ourselves. It doesn't really matter which approach you choose. Your organization might set constraints on what strategies you can use to download. Usually HTTPS works for most folks. So yeah, let's go ahead and do that. I'll give you a few minutes, and then we'll walk through the project a little bit.
Should we fork or should we?
Oh, good question. So as a contributor, you are not likely going to have permissions to the project directly. So if you fork it, you will be able to make changes, push it up to your own branch, and very easily create pull requests to the main project. That's typically the approach that we take. So engineers on our team, they'll either create a fork themselves, or we also fork into our own organization and then contribute to the organization's fork. And that way we can do our own PR reviews internally and then merge them up to the main project here. Yeah, excellent question, Joel. And while we're cloning, I'll explain another concept here based around the way that Spinnaker releases get created. So the master branch is considered mainline. That's like all the functionality that's going to go into the next major release of the Spinnaker platform. But if you're contributing a change or you're targeting a specific version of the API, you're going to want to check out a different branch. And all of the branches in the project are prefixed with this release dash key. And then scrolling all the way to the bottom, you can see the 3 most recent releases, 127, 128, and 129. And so if you need to make a change that's specific to the API version that you're targeting in that version, you'll want to check out that release branch and make your changes there and test them. Now there's some advanced topics we can get into if we want to talk about it after the fact around like which branch you want to target depending on the kind of change you're making. But those are all down the road. So I'll give you about another 2 minutes to make sure you got that all locally, and then I'll see if there are any questions in the chat here. cloning repositories, I'm going to go through the deployment step again. A question in the chat to walk through that. So let me grab my Chrome browser again. Okay. So what we're going to do is, this is going to be the home page for Spinnaker itself, and then you're going to go into the Applications tab. Go ahead and create an application, give it a name, and then enter in an email here. Demo@example.com is fine for the purposes of our demo. Of course, I have to give it a different name since I've already got a demo application. Go ahead and click Create. And so on this view, what you're going to see is clusters view. There's going to be no resources in here since we haven't done a deployment. And you're going to want to go to the Pipelines tab on the left-hand nav. Configure a new pipeline. Give it a name here. And then you'll be dumped in this pipeline creation screen. And so this top view here is like a graphical representation of your pipeline. You can add a whole bunch of stuff in here. We could even do another deploy stage if we wanted to. And then we can create this notion of a graph here by just adding stages with different dependencies. And so let me just get rid of some of these other ones. So in the deploy manifest stage here, go ahead and select an account. There's only going to be one. Grab the Nginx manifest. Scroll past all of the ads. And then just grab this deployment here. And then you can put it into the text box that's in that deploy manifest stage. More complicated or even more realistic pipeline examples, you typically won't embed a text version of the resource here. You'll usually provide it as an artifact, and there's a whole bunch of different ways that that can come through. You can configure those manifests to live in a Git repo, and then you can pull those in even as a trigger from the pipeline. You could render them using Kustomize or Helm. There's just like a number of different ways that you can get the manifest in here. This is just the simplest path for testing purposes. So you'll go ahead and click Save Changes here. And then when you go out, you'll go ahead and back out of that configuration and start a manual execution. Okay. You're getting what now?
Too many pods. It's like the schedule is awesome, too many pods.
I just gave the ATS.
Thank you.
You want? Oh, you want? You scaled it?
Yeah.
Okay, cool.
Yeah. So if you're seeing resource contention issues, we've just scaled up the cluster, so give it a few minutes. Thank you very much, Christos.
We might need another transfer.
Probably.
Sorry.
Yeah. What I'm realizing too is that I scaled the wrong cluster this morning.
As long as you didn't scale down.
Another neat little plug here, I guess, while we're waiting for folks to clone. If you really want to keep stuff organized, a really neat tool inside of the terminal is tmux. If you're not super familiar with it, helps you manage windows. So that's what I'm using here today, a combination of VI for managing these configuration files, and then different splits and windows for keeping all of this organized. And you can name them and reorganize them. You can even create different sessions. So typically what I'll do is I'll have a session per cluster. That way I know, like, when I'm editing configs across clusters, I know exactly where I'm working. So today we'll just be working in the master branch. And what we're going to be doing today is we're going to be adding a stage, and we're going to walk through kind of the layout of Orca at a very high level, and then what we're going to do when we add this stage, and then how we can actually see the service running. So we're going to leave those port forwards going, and we're going to use them once we stand up the Orca service locally. So I'm going to switch over now to IntelliJ, and I'm going to pull this over to the main screen, and I'm going to make this larger. I'm actually going to grab this fella for now. Okay. I don't know if I can make this larger. Does anybody know if we can make the left nav larger?
Usually you have to do like accessibility, like where you can zoom in.
Yeah, command plus did not seem to work here. That's, really? Oh, isn't there like a presentation mode? Should we do that? Where is that? There we go. Hey, look at that. But it doesn't show me the nav. How unfortunate. All right, let's get out of that. And then toolbar, I guess. Okay, you know what? A better way to browse this is maybe going to be in the terminal because I have more control over that. Okay, so let's move back here. And I'll just briefly show you how the project is laid out here. We use a tool called Tree to look at the high-level directories. So Orca is split into a number of different packages. This is actually not a great view. Let's just go look at this view. Okay, so Orca, of course, is the orchestration service within the project. And there's a lot of stuff in here. We're going to touch maybe like 5% of what's in the project today. Really what we want to focus on is in the Orca core project. But what you can see here is that there are integration points for each of the individual services that Orca works with the most. And then it's going to have different packages for the different backing stores, right? And we're not going to dig too much into them because really what we want to focus on today is Orca core. So let's go ahead and how is this going to look? Oh, right. Okay. So let's do maybe a depth of 3. No, that's not even close. How about a depth of 10? That's maybe too much. But it'll give us a sense for what we need to do when we're in here. So are we all familiar with how the core Spinnaker services are? I realize I glossed over entirely like the language and technologies that are used in these services. We talked about what they do, but not... Okay. Good? Okay. All right, so we talked about what they do, but not necessarily how they're actually built. So let me dig into that for a second here. All of the core Spinnaker services that you see are going to be written in a variation of Java. So there's a number of different JVM languages, but they're all going to be based on the JVM. The majority of the project is written in Java. There are places and corners within the project where you will see Groovy, Kotlin. I think there's maybe literally one Scala file, but for the most part, the project is Java. And the technology that we use for all of the services is Spring Boot. Now, thanks to the efforts of David and team here, David who just stepped out, we've just recently upgraded to Spring Boot 2.4, and I believe that'll be coming in the next version of Spinnaker 1.30 or something like that. So some pretty big, I guess, like infrastructure upgrades to the project that are coming soon. So what we want to be able to do today, and I guess I'll just show you the actual services that we want to build, is we want to build a stage. So let me explain this, I guess, first by looking at Deck, and then we'll talk about how this is going to get built in Orca. So let me go to our pipeline here, our application, our demo pipeline, and now this time I really will talk. Okay, so if I go to pipelines and configure deploy, this is a representation of our pipeline graph, right? So remember at the very beginning, we talked about pipelines being a graph that is composed of stages, and those stages are themselves composed of tasks. So when I add a node here, like deploy manifest, it's attaching to the root node. Whenever I add more stages here, they're going to be chained together. And then, let's say we could have a situation like this. I'm just going to keep choosing random stages, but I could make this stage depend on code build. And so now we've got this nice little, fork and then a join at the end here. So the way that Orca is going to interpret this is it's going to organize all the different stages that it needs to execute, and then it's going to execute them in sequence based on when they need to return a result. And then they're going to execute individual tasks in the same way. So a deploy manifest task, for example, is going to have a start, it's going to have an apply, and then it's going to have a monitor. And deploy, the deploy manifest stage is, we can look at the Orca code as well in a moment. But the reason it's doing that is to make sure that your deployment actually worked. So when we go actually run this pipeline, you can see this blue bar here is the current stage that's running. And then if we look at the task status, that's where we can see the graph of tasks that are being run for the deployment here. So you can see there's a number of different things that are encapsulated within a deploy manifest stage. And this is really important because this could be really anything, right? But these are all things that are related to the act of deploying a manifest. So it's easy for your users to say, okay, I'm going to go deploy this manifest, and they don't necessarily have to think about, well, am I going to be able to apply it? Do I need to monitor it? That monitor task is making sure that when this deployment gets rolled out, you might have seen very briefly there was a yellow, like waiting for stable or something like that. I can't remember what the exact label is. But that task is actively sitting there, querying the Kubernetes API and asking, are you stable yet? Are you ready yet? Have you passed your startup readiness, whatever probes? And only once that's done will it move on to the next task here. And you can see that there are timings here. These timings are automatically collected for you. You don't have to calculate these per se. Orca will report those back for you. And then we have our overall status in the project here. So are there questions conceptually about what we're talking about here? So let's go back to our project here, and we'll actually dig into some of the code. So we should be able to go look at deploy manifest. And we can actually look at the implementation for deploy manifest stage. This is actually the test. We don't actually want the test. We want to go to this fella. Perfect. Okay. Let's go ahead and make this a little bit larger, and we'll actually dig into how this gets implemented. So in Java, of course, we can extend different classes. This tells us, that there's like some baseline functionality that we need to implement in order for stage to exist properly within Spinnaker. So there are two different kinds. Well, there's a couple different kinds of stage definition builders. So these are classes that are meant to instruct Spinnaker on what functionality is available within that stage. So when we see expression-aware stage definition builder here, what we're saying is that this class implements the ability for there to be a stage within Spinnaker and for it to render spell expressions. So are we familiar with spell expressions? Is that a new concept? I know you know. Okay, so spell expressions, they stand for the Spring expression language. I think maybe in Spinnaker they stand for the Spinnaker expression language, but the base is the same. They give you the ability to define dynamic values within a pipeline. So let's go back to our example here really quick. Let's say inside of this configure stage, I actually wanted to parameterize the image version that I'm pulling in. I could introduce a spell expression in this text manifest, and that'll be between a $sign and 2 curly brackets. So let me do that real quick here. Say that a stage is buildable through this, like expression builder. We're saying that values that look like this are going to be evaluated within the context of the stage. And we can include this not just in the text manifest, we can also include it in the account if we wanted to parameterize the account we were deploying to. Really anywhere within this stage definition, we can include a spell expression. And we know based on the implementation here that we have to honor that contract. Now there are ways for you to disable expression evaluation, but essentially what we're saying here is that you have the ability to. The individual stage that we're going to be working on today is actually not going to be expression aware. We're just going to use the simpler stage definition builder. So when you're deciding on what kind of functionality you want to include in your task, this is one of the first decisions that you'll make, is like, what is the contract that I want to expose to users of my stage? Then we can see here that we have a number of methods here that we have to override. The one that we want to care about the most is this task graph. So remember that when we're looking at the execution here, we have our graph of stages, and we also have our graph of tasks. So how Deck in particular knows which tasks are exposed is by understanding the task graph that comes from Orca. So all of this stuff we can now see is directly related to the builder here. Here's our resolve manifest task, here's our deploy manifest task, and each of these have their individual implementations. So for example, we can go ahead and look at deploy manifest task, and we can see that it's doing a whole bunch of stuff, right, to actually deploy our manifest. And we can do the same by looking at any of these other tasks. So this is kind of the units of abstraction that you'll be using when you define your own stages. There's also a few things that you can do outside of this. There's like a whole life cycle within pipelines that you can implement. So for example, if you want to take some action after the stage has completed, then you can go ahead and do that. If you want to make your stage retryable or cancelable, those are also hooks that you can define. And what that allows you to do is if, for example, somebody cancels a pipeline and it's currently executing your stage, then you can do some kind of cleanup task, right? Let's say that you left a remote system in an inconsistent state. Implementing that method will give you the ability to clean up resources in that remote service and make sure that you're not creating a mess for yourself internally. And then, of course, these are all a whole bunch of helper methods. But this gives you a flavor for what you can do within stages. And I would recommend using the existing open source stages as kind of a template for the things that you want to be building internally. As there's a number of patterns in there that kind of help you, get the creative juices going for what's possible. So I'll stop there again, and let's see if there are any questions. I'll also monitor the chat, and we'll get started again in about 2 minutes. You should be able to, yeah. I think there's a default implementation. The question was if there's anything cancelable for deploy manifest. I think it's whatever the default implementation is. Right. There's a question in the chat for what is ORT service. So this is a bit of a historical, I'm going to butcher the history here. ORT is the original name for Cloud Driver, I want to say. It was there were two services, ORT and MORT, and I don't recall exactly what the purpose of those services were. Yeah, this is like digging back into, 2014, 2015. But I don't recall exactly off the top of my head what it's currently used for. I think if I understood your question, you're asking what the boundary is for a task? Yeah? Yeah, so the boundary is really whatever decision makes sense to you. In the deploy manifest stage, I know that's kind of a non-answer, but in the deploy manifest stage, you can see they're broken down logically by the things that you would be looking for, right? When you're actually think about it in terms of what you want to communicate to the end user, right? If you want to have this stage could perfectly be implemented by one task that says deploying manifest, and you'll see the duration take as long as the stage. But it's really not helpful to somebody that's trying to understand where this deploy manifest stage failed if there's only one task. So kind of like think about breaking it down into where it makes sense. And there is mechanism for you to pass information along. There's something called a context that will be passed between tasks and stages that you can populate and include custom information. So you could, for example, have a task that's retrieving credentials and then passing it on to some other task within that stage. So I guess the glib TLDR is that there's no hard and fast rule.
But we wouldn't like to leave like sensitive information in the context, not the other. So
Right.
that would be within a task because it's working.
Mhm. Yeah, exactly. Yeah. Okay, so wow, we have 9 minutes here. So I think what we're going to be able to do is start up the Orca service and see it connect to the remote cluster. And then I'll show you the stage that we would be building here. So let me walk through that a little bit, and then we'll start up the service. So a stage can be very, very simple. I've got super secret stage here. Okay. Okay. So what we're defining here is a class mySuperSecretStage. It implements stage definition builder, and then we're of course implementing this cancelable stage to do some, return a different result here if we got canceled, and providing the task graph. So in this case, we're going to, for the sake of example, define a start task and an end task. And we're going to give them labels, and then the implementations themselves are not super complicated. They're just going to return succeeded in all cases, and then they're going to return a output. And an output in this case is a value that can be retrieved by DEC. So this is information. Let's go back to our deploy status here. If you look in the implementation for the deploy manifest stage, all of this information that is described within this white box is something that's defined in the outputs block of that stage. So that's what we're saying here. We're saying here is a stage start status, and in the front end implementation, you can get into this map, grab this key, and then get this hello value. And then we compose this into the higher level stage. Now, let me talk a little bit more about the anatomy of what's going on here. We have this in the Spring Boot world. For those of you that are not as steeped in the Java ecosystem, Spring Boot is known, or Spring more generally is known for a concept called dependency injection, which means that you can define different resources that can then be dynamically loaded at runtime based on what an implementing class is asking for. So the way that we make this stage discoverable to Orca as it's running is to add this component annotation. And so this is a Spring level component, a Spring level annotation that is declaring this class needs to be loaded, especially whenever we're requesting something that implements this stage definition builder. And then to satisfy this interface here, we're going to override the particular values here. There's a number of different helpers, right? This builder is an example of a helper that you can use to actually get all of this stuff running. And unfortunately, we're not going to have a ton of time to dig into this today. So let's at least go ahead and get the service started, and then I'll tell you where you can go to get more detail to kind of continue the workshop at your own pace, and we'll talk about the cluster that you're working in and kind of the parameters there. So let me pause for a second and get set up again. Okay, so what we're going to want to do, let's make sure that this is, all of the run stuff is gone. But let's go ahead up to run here, and let's just go ahead and edit our configurations. What we're going to want to do is you'll either have a little like collection up here of like a little toolbar that will help you run services. Otherwise, what you can do is you can go to the run task up here. This is all IntelliJ specific, by the way. We'll talk about what to do if you're not wanting to use the inbuilt IntelliJ stuff. You want to create a Gradle task that includes Orca Web. So Orca Web is where all of the like service definitions are, all the controllers in Spring that are going to respond to requests. And then there is a particular plugin that we'll want to install, and I'll show you that in a moment, called nfile, We'll go ahead and enable that, and we'll add a .env file. And this is the wrong project. So let's just go down to Orca, wherever Orca is. Let me set this down again. I want to set this to whatever file. The reason I'm setting it to whatever file is because your Finder settings probably are not showing hidden files. And we're going to want to set this to telepresence env, right? And that file, of course, will get created once we run telepresence itself locally. And so what we want to do here, it's time to, I guess, get a little bit more conceptual again, is we're going to run the service locally after we've run telepresence. And what telepresence is going to do for us is it's going to create a bidirectional proxy from our local machine to our remote Kubernetes cluster. And the way that it accomplishes this is if we go look at our kubectl again and we do go look at our pods. What telepresence is going to do is we're going to tell it a deployment to impersonate, and it's going to actually replace the running pods for that deployment with a telepresence container that is going to create that proxy. So for example, if we're going to go ahead and use telepresence on Orca, usually what you will see is you will see a much longer string here, like the hash ends up getting much longer, and when you describe that pod, it'll be the telepresence node that you're actually going to be using. Once you've done that, you're going to get a whole bunch of environment variables. What telepresence is doing under the hood is it's actually mounting the file system from the container onto your local machine. So that's going to give you access to all of the environment variables that Kubernetes is setting. And then it's also going to muck with your DNS to make sure that things like, spin.clouddriver.my namespace is working. So you should be able to do that all locally and pretty transparently. And so the reason we want that .m telepresence file is because in IntelliJ, we want IntelliJ to be able to pick up those values so that your local Orca instance is actually talking to the remote cluster. Okay, so we should be able to run that, and then I will show you how to actually run the service if you're not using IntelliJ. So let me go back to Kitty here, the terminal emulator, and I'm going to do a /Gradle. Because I'm in the wrong directory. I need to go back to the root of the project, and then I can do a Gradle build. Just for the sake of brevity, I'm going to run this -sx check, and I'll explain what's going on here. So /gradlew, if you're not familiar with the Java space, Gradle is the build tool that we use inside of the Spinnaker project. It comes with a shell script in the project itself, and it'll download the right version of Gradle, and then it'll read the task graph that it needs to do for a build, for example, in the local project. Now that -x check value that I put at the end there, -x is saying exclude this task from the build, and I'm excluding check, which in this case is a shorthand for test, integration test, a whole bunch of other stuff. So just so that we get a build, we see a build running here. We should see this successfully complete, and then once we've done that, we can also do a run, and we should see the service run, although it's probably going to fail since I don't have stuff forwarded locally. So with the understanding that we have exactly 1 minute left here, I'm going to show you how you can continue this workshop at your own pace. So if you go to handy dandy YouTube here, and you go to the Spinnaker channel, we can see a preview for whatever this is. I can't even read that. Okay, let's go here and let's look for Spinnaker YouTube channel. Where's the Spinnaker channel? I guess let's just Google Spinnaker YouTube channel, since I don't have that link handy. This seems fine. Make sure that we don't actually play this. And if you go down to the Spinnaker channel here, go to the videos list, you should be able to search in here. And if you search for Gardening Days workshop, There you go. So you should see this new Spin Contributors Workshop. You get to listen to me for another 2 or so odd hours, but we'll actually work through the Orca definition. We'll walk through that IntelliJ setup again, so you're not just hearing me talk through it. And you'll also get to look at the modifications that you'll make to deck. So at the end of that workshop, what you should be able to do is have a new stage that you can run within your Spinnaker cluster. And what we're going to do with this particular cluster that you have access to is we're actually going to leave it up through the remainder of this week. So if you're going to KubeCon, feel free to enjoy the conference. And as you have time, work through it. We'll tear down the cluster at the end of this week. But again, all of these instructions you can follow through on at your own pace. So with that, thank you for coming. Hope you learned a lot of stuff. And if you have questions, I'll be around the rest of today. I'll be at KubeCon, so if you want to come by the Armory booth, I'm happy to answer questions as well. Thank you to Christos, Brian, Alfredo here for helping out today. And hope you have a great rest of the conference.